The definition of dispensing in the fire code is to transfer or apply a substance or agent from one container or receptacle to another, whether for use, storage, or disposal. Based on this definition, any lubrication pit where grease or oil is transferred from a bulk container to a smaller container, such as a grease gun or oil can for application to vehicles, would be considered a dispensing pit. The National Electrical Code, specifically the 2002 edition in this case, does not provide a specific definition for dispensing in the context of lubrication pits. However, based on the fire code definition, it is reasonable to conclude that a lubrication pit where grease or oil is transferred from bulk containers for application to vehicles would be classified as a Class 1, Division 2 location. Table 514.3 of the National Electrical Code 2002 provides that a lubrication pit without dispensing may be unclassified if specific ventilation conditions are met. Since the pit would be considered a dispensing pit, this unclassified exception does not apply. Therefore, it is likely that a lubrication pit in a quick lube facility where grease and oil are transferred from bulk containers for application to vehicles would be classified as a Class 1, Division 2 location. Let's delve into the specifics of Class 1, Division 2 locations and the implications for electrical installations within such environments. Class 1 locations are those where flammable gases, vapors, or liquids are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 further defines this as a location where ignitable concentrations of flammable gases, vapors, or liquids are present, but are either normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or are normally prevented by positive mechanical ventilation, and may become hazardous through failure or abnormal operation of the ventilating equipment, or are adjacent to a Class 1, Division 1 location, and occasionally communicated. Given this classification, electrical equipment installed in a Class 1, Division 2 location must be designed and installed to minimize the risk of ignition. This typically involves using explosion-proof enclosures, intrinsically safe circuits, or other methods to prevent sparks or hot surfaces from igniting the flammable materials. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure, preventing it from propagating to the surrounding atmosphere. Intrinsically safe circuits limit the energy available in the circuit to a level that is too low to cause ignition even in the presence of flammable materials. Ventilation plays a crucial role in mitigating the hazards associated with flammable materials. In the case of lubrication pits, ventilation systems are designed to remove any accumulated vapors or gases, preventing them from reaching explosive concentrations. However, as mentioned earlier, if the pit is used for dispensing, the ventilation exception for unclassified locations does not apply, and the area must be classified as Class 1, Division 2. Now, let's consider the specific requirements for electrical installations in Class 1, Division 2 locations. Article 501 of the National Electrical Code provides detailed guidance on the types of wiring methods, equipment, and procedures that are permitted in these areas. Some of the key requirements include firstly the use of rigid metal conduit, intermediate metal conduit, or cable with a gas-tight continuous metallic sheath. Secondly, sealing fittings are required to prevent the passage of gases, vapors, or flames from one portion of the electrical system to another. Thirdly, equipment must be approved for use in Class 1, Division 2 locations, meaning it has been tested and certified to meet the applicable safety standards. Fourthly, special attention must be given to grounding and bonding to minimize the risk of static discharge. Fifthly, control equipment, such as switches and circuit breakers, must be installed in explosion-proof enclosures or be intrinsically safe. In addition to these general requirements, there may be specific requirements for certain types of equipment or installations. For example, lighting fixtures in Class 1, Division 2 locations must be designed to prevent the escape of sparks or hot particles. Motors must be either explosion-proof or be designed to prevent ignition of flammable materials. Wiring methods must be selected to withstand the corrosive effects of the environment. When designing electrical systems for lubrication pits, It is essential to carefully consider the specific hazards present and to select equipment and wiring methods that are appropriate for the Class 1, Division 2 classification. It is also important to ensure that the installation meets all applicable requirements of the National Electrical Code and any other local codes or regulations. Furthermore, regular inspections and maintenance are necessary to ensure that the electrical system continues to operate safely and effectively. This includes checking for any signs of damage or deterioration, testing the functionality of safety devices, and verifying that all equipment is properly grounded and bonded. Proper documentation is also crucial for managing electrical safety in hazardous locations. This includes maintaining accurate records of all electrical equipment, wiring methods, and safety procedures. It also includes providing training to employees who work in these areas on the hazards associated with flammable materials and the proper procedures for operating and maintaining electrical equipment. Now, let's examine Table 514.3 of the National Electrical Code 2002, which provides specific ventilation conditions under which a lubrication pit without dispensing may be considered and classified. According to this table, the pit must be provided with mechanical ventilation that is interlocked with the lighting and any other electrical equipment in the pit. The ventilation system must be designed to provide a minimum air velocity of 1 foot per minute across the entire pit area. The ventilation system must also be designed to prevent the accumulation of flammable vapors or gases. In addition to these ventilation requirements, the pit must also be equipped with a combustible gas detection system that will automatically shut down the electrical equipment in the pit if a flammable gas concentration exceeds a certain level. The combustible gas detection system must be calibrated and maintained in accordance with the manufacturer's instructions. If all of these conditions are met, the lubrication pit may be considered and classified, meaning that it does not need to meet the requirements for Class 1, Division 2 location. However, as we have already established, this exception only applies to lubrication pits without dispensing. If the pit is used for dispensing flammable liquids or gases, it must be classified as a Class 1, Division 2 location regardless of the ventilation system. In conclusion, the classification of lubrication pits under the National Electrical Code depends on whether or not the pit is used for dispensing flammable liquids or gases. If the pit is used for dispensing, it must be classified as a Class 1, Division 2 location and must meet all of the applicable requirements for electrical installations in hazardous locations. If the pit is not used for dispensing, it may be considered and classified if it meets the specific ventilation conditions outlined in Table 514.3 of the National Electrical Code 2002. When making decisions about the classification of lubrication pits, it is important to carefully consider the specific hazards present and to consult with qualified electrical engineers and inspectors. It is also important to stay up to date on the latest revisions to the National Electrical Code and any other applicable codes or regulations. Understanding the definition of dispensing and its impact on the classification of lubrication pits is crucial for ensuring electrical safety in these environments. By following the requirements of the National Electrical Code and implementing appropriate safety measures, it is possible to minimize the risk of fire or explosion and to protect workers from harm. Let's further clarify the requirements for electrical equipment in Class 1, Division 2 locations, focusing on specific types of equipment commonly found in lubrication pits. Lighting fixtures in Class 1, Division 2 locations must be designed to prevent the escape of sparks or hot particles that could ignite flammable vapors or gases. This typically involves using enclosed and gasketed fixtures with lenses made of impact-resistant materials. The fixtures must also be marked to indicate that they are approved for use in Class 1, Division 2 locations. Motors used in Class 1, Division 2 locations must be either explosion-proof or be designed to prevent the ignition of flammable materials. Explosion-proof motors are constructed with enclosures that can contain any internal explosion without allowing it to propagate to the surrounding atmosphere. Non-explosion-proof motors must be designed to prevent the surface temperature from exceeding the ignition temperature of the flammable materials present. Wiring methods in Class 1, Division 2 locations must be selected to withstand the corrosive effects of the environment and to provide a reliable electrical connection. Rigid metal conduit, intermediate metal conduit, or cable with a gas-tight continuous metallic sheath are commonly used wiring methods. Sealing fittings are required to prevent the passage of gases, vapors, or flames from one portion of the electrical system to another. Control equipment such as switches, circuit breakers, and motor starters must be installed in explosion-proof enclosures or be intrinsically safe. Explosion-proof enclosures are designed to contain any internal explosion without allowing it to propagate to the surrounding atmosphere. Intrinsically safe circuits limit the energy available in the circuit to a level that is too low to cause ignition, even in the presence of flammable materials. Grounding and bonding are critical for minimizing the risk of static discharge in Class 1, Division 2 locations. All metal parts of the electrical system must be properly grounded and bonded to provide a lower impedance path for fault currents. Static electricity can accumulate on non-conductive surfaces, and a static discharge can ignite flammable vapors or gases. Combustible gas detection systems are often used in lubrication pits to monitor the concentration of flammable vapors or gases. These systems consist of sensors that detect the presence of flammable materials and a control panel that activates an alarm or shuts down the electrical equipment if the concentration exceeds a certain level. The combustible gas detection system must be calibrated and maintained in accordance with the manufacturer's instructions. In addition to these specific requirements for electrical equipment, there are also general safety precautions that should be followed in Class 1, Division 2 locations. These include firstly, prohibiting smoking and other sources of ignition. Secondly, using only approved tools and equipment. Thirdly, wearing appropriate personal protective equipment such as flame-resistant clothing and safety shoes. Fourthly, following established procedures for working with flammable materials. Fifthly, providing training to employees on the hazards associated with flammable materials and the proper safety procedures. Let's now consider some of the potential challenges and solutions associated with designing and installing electrical systems in Class 1, Division 2 lubrication pits. One challenge is the limited space available in many lubrication pits. This can make it difficult to install and maintain electrical equipment, especially explosion-proof enclosures. One solution is to use compact equipment and wiring methods that minimize the amount of space required. Another solution is to locate some of the electrical equipment outside of the pit in a non-hazardous location. Another challenge is the corrosive environment in many lubrication pits. Exposure to oil, grease, and other chemicals can damage electrical equipment and wiring. One solution is to use equipment and wiring methods that are specifically designed to withstand corrosive environments. Another solution is to provide regular cleaning and maintenance to prevent the accumulation of corrosive materials. A further challenge is the potential for mechanical damage to electrical equipment and wiring. Lubrication pits are often busy environments with vehicles and equipment moving around. One solution is to protect electrical equipment and wiring from mechanical damage by using guards, barriers, or other protective measures. Another solution is to locate electrical equipment in areas where it is less likely to be damaged. It is also important to consider the specific needs of the lubrication pit when designing the electrical system. For example, some lubrication pits may require explosion-proof lighting to provide adequate illumination. Others may require special grounding and bonding systems to prevent static discharge. By carefully considering the specific hazards and requirements of each lubrication pit, it is possible to design and install an electrical system that is both safe and efficient. In conclusion, the design and installation of electrical systems in Class 1, Division 2 lubrication pits require careful attention to detail and a thorough understanding of the National Electrical Code and other applicable codes and regulations. By following the requirements of the code and implementing appropriate safety measures, it is possible to minimize the risk of fire or explosion and to protect workers from harm. Regular inspections and maintenance are essential for ensuring that the electrical system continues to operate safely and effectively. It is also important to provide training to employees on the hazards associated with flammable materials and the proper safety procedures. By working together, electrical engineers, inspectors, and lubrication pit operators can create a safe and productive work environment.